All right, we were working on day 39. This was actually the third part. We played a game, and the game looked something like this. And what we were going to do now with the game down here, we played a betting game, and we found the expected value. And what we want to do now is we were working on finding the standard deviation. The standard deviation, the formula, was on the next page. We started working with that. The formula for the standard deviation of a discrete random variable, a probability model, was the sum of every x value minus the expected value squared times the probability. So the way we worked that out, we started down here. I'm just going to do this on a separate page so we can look at our table at the same time that we had. So if we look at the game that we played from the previous set of notes, right here, we would like to find the standard deviation now that goes with that. So the standard deviation is equal to the square root of the sum of every x value minus the mean, the expected value squared, times the probability. So basically what you do is you calculate, you take every x value, so every x value, there are 4 x values, 0, 5, 10, and 100, and from each of those you're going to subtract the expected value, which was $3.65. You're going to square that, and then you're going to take it times the probability that went with 0, which is 36 over 52. You're going to add to that the same thing with the next x value and its probability. So the next x value is 5 minus the expected value, square it, times its probability, which is 12 over 52. Plus, now we take the next x value, which is 10. We take away from it the expected value, 365. We square it. We multiply it by its probability, 3 out of 52. And then we add to that the last x value, which is 100. We take away the mean, the expected value, squared, times its probability, which is 1 out of 52. Then we take the square root of this whole thing, and that is the standard deviation of x. Now, before we take the standard deviation squared is the variance. We'll find that too. So if you do this calculation, you get that the standard deviation of this is $13.12, I believe. So that means that on average, your winnings will be plus or minus $13 above the $3.65. So on average, your winnings will be plus or minus $13. So 13 above or below, $13 above or below $3.65. Okay, the variance, if you square that, if you take the standard deviation squared, you get the variance, and that is 172, not 17.2, 172.31344. Okay, so you just square it, and that's the variance. All right, so now we're going to look at a probability problem, probability distribution problem with class 15 boys and 10 girls. And we're randomly going to select 2 students for a committee. We're going to create a probability model for the number of girls in the sample, and then calculate and interpret the mean and standard deviation of the number of girls. So basically we've got this scenario. We've got 15 girls and 10 boys, and we're going to choose 2 people. So every time we choose 2 people, we're going to make a 2-person committee. We've got some options. The first thing that could happen is we could choose a boy, and the probability that we choose a boy first would be 10 out of 25. Okay, so the probability that I choose a boy is 10 out of 25. The probability that I choose a girl first is 15 out of 25. Okay, so I've got my first person that I choose for my committee could be either a boy or a girl, and those are the probabilities. Now if I choose the boy first, for the second person I could choose a girl or a boy. So now the second time, the probability that I pick a boy, the second time is different because I already picked a boy. So now there's 9 boys out of 24 people. So to find the probability of getting a boy and a boy, that would be 10 out of 25 times 9 out of 24. So I can do that calculation and figure it out, and that ends up being 0.15. All right, so now I choose a boy first. I already choose the boy second, so now I need to look at what else could happen. I could choose a girl second. So if I choose a girl second, there's only 24 people left, 24, because I already chose one person, which was a boy. But now the next person that I choose is out of 15, because there's still 15 girls. So the probability of getting a boy and then a girl is equal to 10 out of 25 times 15 out of 24. And that gives us 0.25. Okay, so now the other scenario is if I picked a girl first. If I pick a girl first, I could pick a boy second or a girl second. So then following this branch, so the probability of getting a boy second is 10 out of 24. So the probability of getting a girl and then a boy is 15 out of 25 times 10 out of 24, which is another 0.25. And then finally, picking a girl first is 15 out of 25 and a girl second is 14 out of 24. So the probability of getting a girl and a girl is 15 out of 25 times 14 out of 24. And that is 0.35. So let's make sure these add up to 1. Yes, they do. All right, so now we need to look at, in each of these scenarios, how many girls. So basically the number of girls is what I'm looking for in these scenarios. Because now below here I'm going to make a probability distribution where I have my X is the number of girls that I have on my committee and the probability of each of those. So the X values in this one, I've got 2 boys, so I have 0 girls. In this one I have 1 girl, 2 girls. So my probability distribution, I have 0, 1, and 2 possible girls. So the scenarios that give me 0 girls, the probability was 0.15. The scenario, there's only one that gives me 2 girls, and that probability was 0.35. The 2 that give me 1 girl, I have to add those up because I could get a 1 girl this way or this way, so that's 0.5. So the probability distributions are sometimes you have to make a tree diagram to get the probability distribution. Now we can find the mean or the expected value. These are just, it's the same thing. This would be the mean or expected value. In other words, if you were to select a committee of 2 over and over, select 2, put them back, select 2, put them back, select 2, put them back from this class, in the long run, how many girls would you expect to get? So the average, the mean. So the mean or expected value is basically the sum of every X value times its probability. So we take every X value, 0, 1, and 2, times its probability. So 0 times 0.15 plus 1 times 0.5 plus 2 times 0.35. So 0 times 0.15 plus 1 times 0.5 plus 2 times 0.35, and that gives me, on average, 1.2 girls. 1.2 girls on average. So I can expect to have 1.2 girls in each group. So now the standard deviation, I'm going to take the square root of every X value, 0, minus the expected value, 1.2, square it, and then multiply it times its probability, 0.15, plus the next X value, which was 1 girl, minus 1.2 girls, the expected number of girls, squared, times its probability of 0.5, plus 2, the next X value, 2 minus 1.2 squared times its probability, 0.35. So we work all that out, and all right, so when we do all this calculation, we get that the standard deviation is the square root of 0.46. All this works out under here to be 0.46, which is 0.678. So when I select this group of girls, or this committee, on average I can expect to have 1.2 girls with a standard deviation of about 2/3 of a girl above and below. So in other words, we're basically saying between 0 and 2 girls. And the variance is 0.46 if you square that. So now your homework is number 35. Again, lots of odd problems, some reading to do. So next video will be day 40, chapter 16.